Hello everyone. We are going to continue the previous session in which we created this game, and we are now going to display a counter on an LCD screen, and the counter will display how many tries have actually happened and how many times the person has won. For that, I need an LCD panel. So let's have an LCD panel, a 16 by 2. I will use the I2C1. I don't want to do so many connections. All right. Let us connect these. The ground. Let us connect to the ground. Flag. VCC. We'll connect it to VCC, which is red. You know that SDA and SCL, they are connected to analog pins A4. They are always connected there, and SCL is connected to analog pin A5. Let's color these as purple maybe. Okay. All right, we have set it up. Let us start the simulation and see. All right, we have not displayed anything on the screen, so let us display something on the screen. Okay, for this I need to include a library, and the library is liquid crystal dot whatever. So hash include liquid crystal underscore I2C dot h. Then I need to create an object of liquid crystal type. So I'll say liquid crystal underscore I2C, and name it LCD, and we need to give it the starting address. That starting address is 0x20, I believe. 0x20, sorry, 0x20, comma, how many uh, characters in each row and how many rows. Okay, so we need to specify that. So these are the two things that we need to do. First of all, include the library first, then create the object. The object is now going to be called LCD, and I'm going to initialize LCD here, somewhere here. So I'll just say LCD.init function. That is to initialize the LCD. And let us switch on the backlight of this also. So I'll say LCD dot backlight function, backlight function. This part done. Now I need to display something. So what do I need to display? I'll display something on the top left corner. So I will be displaying it somewhere. After everything has happened, I'll display something. So let us see what we need to display. Let us use a counter now. So I will need a counter. So I will have a counter called tries, which is 0. And I will take another counter called wins, which is equal to 0 in the beginning. So, okay. Now what do we do? We say every time somebody clicks, how do we know whether somebody has clicked? Now, with the current configuration, we cannot know whether somebody has clicked heads or tails. Why? Because if somebody clicks on tails, this LED lights up, but there is nothing going back to the Arduino saying that it is actually this tails has been pressed. Similarly, if somebody clicks on this particular switch, there is nothing going back to the Arduino saying that this particular switch has been pressed. Regarding this switch, we already have made a system of sending signal back to the Arduino. Yes, but from here we cannot. According to the current situation, we cannot. And this switch is made to take value from the Arduino and output from the Arduino and send it to the LED. But it can do only one thing. So that means it can only take value from the Arduino and take it to the LED. Now I cannot do two things from here. That means I cannot take the value from Arduino and give a value back to Arduino. That cannot be done. So how do we do that? For this, we will be using a DP/DT switch now. Earlier we had used something called as SPDT switch. Now we will be using DP/DT switch, DP/DT relay. And let us see now what a DP/DT relay looks like. Um, a DP/DT relay is actually double pole, double terminal. So that means now you can see that there is one coil, right? There is a single coil. Okay? But there are two circuits now. You can see this is the common and this is the NC and this is the NO for one of the circuits. And on the lower side, this is the common and this is the NC and this is the NO for the other circuit, right? And there are a total of 1, 2, 3, 4, 5, 6, 7, 8 terminals, and these are the terminals that we will be using. All right. So you can see that the terminals on the particular relay are actually created exactly as per this diagram. So these two right now are the two parts of the relay now. Terminal number 1 and 16 are part of the coil. Okay. This is the common for one of the circuits. This is the NC for this one circuit, and this is NO for one circuit. Similarly, this is common for the second one, common NC for the second one, and this is NO for the second one. Why am I showing you all this? Why the first one and the second one? Is because we are basically trying to create using a single switch which will actually activate this particular coil. Using this particular coil, we can activate two switches at the same time. So using one switch, I can activate this particular coil, and using that activation of this coil, I can activate two switches inside this particular relay. And one will actually be switching on the LED, and second one will be sending the information back to Arduino saying something has been done. Something has been fixed. Okay. I hope this part is clear to you. We will now be using this particular thing here. Okay. Uh, we can remove this part, and because let's not have too much of ruckus here. I have removed all the extra components from this from the breadboard. I have left the reset system intact. Okay, so reset system is not going to be touched at all. So we are going to insert our DP/DT somewhere here. Please remember we are going to use these terminals, that is terminal 1 and 16, as the one for coil, for the coil. Okay. Let us arm the coil first. Okay, so how do we arm the coil? Through the switch. Okay, so let us connect this through the switch. Let me just remove all these components from to one side so they don't disturb us. And let's have on the positive side, let us connect one side of the switch to positive and the second side of the switch to one part of the coil. So now the switch is connected, positive is connected through the switch and going to terminal number 1. And terminal 16 is going to be grounded. So let us ground this. So that is ground. So this means when I press this switch, this particular uh, DPDT is going to be activated. Let me bring this wire somewhere here so that it does not disturb the rest of the cable. We'll shift it as needed. Now we will use terminal 4, 6 and 8 for one part of the circuit and terminal number 13, 11 and 9 for the other part of the circuit. So let's work on one part of the circuit. The one part of the circuit is basically the LED. So LED we will connect, okay, we will directly connect it to power at the moment. So let's actually use cable. Let's arm this positive side also, so that this this railing is also armed now. Both the railings are armed. So we need to give power to the LED, and we are giving it direct power at the moment. Let's not worry about the program at the moment. Let's worry about just checking the system whether the system works fine. So what we are going to do is, this is the common, so this is going to get the power. So we are giving it power. And because at the moment this is going to be normally open, this is going to get closed when the system is the coil is armed. So we are going to use this one for the positive. So we will bring the thing here and bring it to number 5. So this is the terminal which is basically connected, right? I hope there is nothing connected here, nothing is connected to this side. So we'll connect the resistor on this side and connect, let's see, let's have this one because this is actually connected to this side. So we'll have this connected to ground. So I think that part of the circuit is done. So that means when I press this switch, this coil is going to get armed and this LED should get switched on. Right now I'm not working on the program at the moment. So it is getting power on the, it is getting direct power on terminal number 4, which is the common, and the normally open should get power from, should get switched on, and this LED should get switched on. Let's see if this works. So when I, yes, so it is working. So this means when I press this switch, the coil gets armed, the normally open becomes closed, and this LED is switched on. So what we are going to do is we will remove this wire and bring the wire from there to this side as required by the program. But let's take the other part of the DPDT also. The other side of the DPDT should actually give a high. The moment I switch it on, it should give a high to one of the pins so that the Arduino comes to know that the switch has been switched on. So where are we going to give that? Let's give this that signal. Okay, at the moment we will give it power from here, which is normally this is the common. So we'll give it the power, and the output from here should actually go to one of the terminals. We'll not use 5 or 6, we'll use somewhere around 10 or 11. So I'm going to give it to 10 to figure it out. Okay, so the input is going to go to number 10. So number 10, the moment I press this switch, what is going to happen is through the DPDT, through one part of the DPDT, it is going to switch on the LED. From the other side of the DPDT, it is going to send a high to pin number 11, pin number 10, that this switch has been pressed. Okay. Let's see. One side of the switch for heads was number 5. So from number 5, we'll send the output here, and we'll remove that wire. We'll remove that wire which was sending a direct high from there, and we'll actually give a high to the common. That high is actually going to come from pin number 5. So if pin number 5 is actually giving a high, it will actually reach at the LED, and if it is not sending a high, the LED will not light up. So what is going to happen now? When I press this switch, two things are going to happen. One is, if number 5 is sending a high to the DPDT, that high will reach the LED and LED will get switched on. And alternate same at the same time, the other part of the DPDT is going to send a high to pin number 10, and pin number 10 is going to know that the button has been pressed. So this press of the switch is basically going to do two things. Okay. Now I am going to replicate this particular circuit again in uh, so let's see that. So I'll make a copy of this over here. Let's okay, bring it here. Okay. And let me bring the switch to the cap of 1. Yes. The LED directly above the last pin. The Let me make a copy of the resistance also, and let us have a cap of 1 so that it doesn't coincide with the switch. And let us connect these two and make it as planned. Now, the second pin was tails was pin number 6. So pin number 6 should actually give the power somewhere here. Where is the common? This is the common. So we'll bring it somewhere here. So same copy. Alright. What else is left? I need to arm this. So the switch is going to get power from here. Power is red. Then this is going to give power to the terminal, the coil, one part terminal of the coil, and the second terminal of the coil is going to be grounded. So let us ground that. So that grounding is also done. Uh, the switch has been given power. Why is this line crooked? Let me make it straight. So what else is left? I need to power, send a signal back to uh, from here. I need to send a signal back to the Arduino that this switch has been pressed. So let's see. I'll use pin number 11 for that. Okay, so what color did I use there? I used red color. I'll use red. Next is the N. The common of this is going to be given power. So we'll give it power. Now this part of the thing is done. Alright, the system is complete. There was some correction which was done over here. The resistance over here was actually placed at this location, which is incorrect because that is directly connected to terminal 2A and 2B. So both of them are directly connected, so they are directly connected to the resistance. So it should actually have been here. Now it is fine. Okay, so just make this correction now. Now let us see whether things are working fine. Okay, so let's start it off. If I want the left side of the switch, so I'll press. So this is not switching on. So the second one should switch on. Yes, and again switch one is not switching on. Okay. So when I reset, let's check the first one. This is switching on now. The second one is not switching on now. So perfect. This part of the program is fine. All right. Now let's worry about how the feedback from the switches is, that is the DPTT basically, is actually reaching the Arduino, and how is it actually going to use it. Let's see, pin number 10 and 11 are going to be used. So let us consider the left one as tails and right one as heads. So let's make a note that way. Let's make a note so that we don't, so it is actually tails on this side. If I make a copy of this, it is actually going to be heads on this side. Alright, so yeah, let's see how the system from the tails is actually going back to the Arduino. So where is it actually going? It is going through the common of the DPDT to the normally open of the DPDT back to Arduino, and that is pin number 10. So tails is actually pin number 10. So let's create some pins. So int tails feedback pin is equal to 10, I believe that was it. And I'll make a copy of this again. And this is int, I'll leave this as heads, feedback pin is equal to 11. So that means pin 11 is actually getting feedback from the heads wala DPDT, that heads wala switch has been pressed. Okay, so let's figure out how do we set up those pins. So that is going to be pin mode in bracket tails feedback pin comma, it is going to be an input. Okay, and let's make a copy of this whole thing, and it is now heads. Okay, what do we do when we need to figure out whether when the heads was pressed or tails was pressed. How do we figure that out? We need the feedback. So let's say tails feedback FB TFB is equal to digital read of tails feedback, and we'll make heads feedback is equal to digital read. This is going to be heads. All right. Okay, so we have actually taken the feedback from the tails feedback pin and heads feedback pin, and we have decided now that 0 is going to be used for tails and 1 is going to be used for heads. So now let's figure this out. That means now if Rx is 0, this means tails is going to lose, right? Right? Tails is going to lose. Now if Rx is 0 and over here if if TFB is giving me a feedback, that means uh, the tails wala switch is giving me a feedback. So how do I know whether it has given me a feedback? So I'll say if TFB is equal to high, that means TFB has given me a feedback. Then I'll do something. Let us do these corrections. We are thinking that if Rx is 0, then tails will lose. So tails will lose. So tails should actually get a low and heads should get a high. And this should get reversed when Rx is 1. So this should actually get a high and this should get a low. So if Rx is 0, then we are writing tails lose. I hope this spelling is right. Alright, so if Rx is 0 and I'm getting a feedback that TFB was pressed. So TFB was pressed. So what are we going to do? Uh, what does it mean? Getting feedback that tails was pressed. So don't you think the guy has actually lost this? Yes. So I'm going to increase the tries, but I'm not going to increase the wins. All right. So I'll say tries plus plus. Tries are going to increase, but that is not going to increase. So else, I'm going to check if heads feedback is equal to high. If this is equal to high, then what happens? Then tries are going to increase and wins are also going to increase. All right. Now, this is going to get reversed in the other part. So when I say if HFB is equal to high, then tries plus plus. If TFB is equal to high, then tries plus plus and wins plus plus. So because tails is going to win. And once after we do this, then that's it. Let us check out what is the system. How is it working now? Let's start our serial monitor thing, 9600, and let us display the values of wins and losses. So serial dot print I'm going to make a copy of this. Okay, so we are going to say tries, not tries. Tries is so many, and we'll display the value of tries. Then move the cursor to the next line. Then we are going to say wins and println. Okay. Let's see what does the serial monitor show now. Okay. So we are initializing. Let's move this whole thing to one side because we actually need this the serial monitor thing. Alright. Saying tries, okay, tries is increasing all the time. Okay, we need to figure out how to stop the tries now. When we see the simulation now, I have actually changed the code a little bit. I have displayed the TFB and HFB status also. What is it actually should be displaying? You can see that TFB, HFB, both of them are actually displaying a 1. What is a 1 here? I have not pressed any switch. So why are these pins getting a high? Okay, if you remember, if you don't press a switch, you get an indefinite kind of an input for on a pin. That means I have to use a pull up or a pull down kind of a thing, right? So we need to put some resistances. So I have put two resistances which are actually pulling it down. That means if this particular pin is not getting anything, it actually gets a low. Okay, so similar to this one, where with this pin, if it is not getting a high from this particular pin, it actually goes to a low. So similarly, we pull it down. So that means this pin, which pin number 10, when it is not getting anything from this terminal line, it actually gets a low. So we have now figured out how things should happen. Let's see now. Let me show you the system. Right now, TFB and HFB, both of them are giving us 0. And when I press the first one, that is the tail one, you can see that the TFB is actually getting a 1. And when I press the heads one, the heads one is actually getting a 1. Right? And you can see that the heads, the LED is also getting switched on. But now, when I click on, see, the wins have increased. Let us see now why is the win increasing when actually I have pressed the tails voila. Because actually the heads should be winning. Right? Let's see the code how. Okay, I have made some corrections here. The corrections are that SW heads were actually written as 5 over here, whereas heads is actually connected to heads is the right wala switch, and it is connected to pin number that is this one, that is connected to pin number 6, and this tails one is connected to pin number 5. So that code was changed, and after changing that code, uh, let us figure out how things happen. Okay, all right. Let's see the serial monitor. I have not pressed TFB or HFB, no problem. Let us press one of them. So let us press the tails, and because tails was supposed to win, I pressed it twice actually. So it is actually showing 2 tries and 2 wins. And when I click on this again, it is now 3 tries and 3 wins. I click on this again, 4 tries and 4 wins. But now if I click on the heads wala switch, it is now 5 tries and 4 wins. Why? Because I have tried once and it was not a win. I click again, it is 7 tries and 4 wins. So it is actually, it will keep on increasing the tries when actually we are pressing the incorrect button. And when we press on the correct button, it is actually, now it has increased the price to price, price has increased, but wins has also increased. Let's click on the thing again. It's 9 and 6. So what happens if I reset it? And after resetting, okay, again the tails is winning. After resetting, now the heads is supposed to win. So it is now 11 and 7. It is again 12 and 7. Now it is not increasing. Why? Because I am clicking on the incorrect LED. Now if I click on the HFB thing, it should increase. It is now increased to 8. It has now increased to 9. It has now increased to 10 and so on and so forth. Now we have managed to write a program which actually calculates the tries and wins, but we still need to make it better. How are we going to make it better? Is that I should not be allowed to keep on clicking on one if I know that if I know this is going to win, I should not be allowed to keep on clicking on it. So that means my one turn should be over and the reset should be automatic. So that means it should automatically reset after I have actually clicked on one of the heads or tails. So this means the system should check whether what you have pressed, give you the score, the wins, and increase the tries, and change the thing automatically. So now I would not need the reset button anymore now. So in the next program, in the next video, we are going to do that. In that section, in that video, we are actually going to remove the reset button altogether. And what is going to happen if I press the heads or tails? If head wins, I get a score, and it automatically changes the RX. It automatically changes the RX. Okay, whether I lose or win doesn't matter. It changes the RX, and now randomly the LEDs are going to change. So I hope you have understood this. If you have any problem, I'll just write a comment, and I'll see you in the next video.